Hello and welcome to the Mastering Ansys CFD course. This is the second workshop and the title of this workshop is the NACA 0012 Airfoil Geometry and Domain Creation in the Ansys Design Modeler. The method I am teaching you is generic, so you can apply on the any airfoil geometry, and the domain creation for 2D cases is again generic, so you can apply even other than any cases of the airfoil. So here is the contents you will learn in this workshop: the airfoil nomenclature, how to get the coordinates of the NACA airfoils, and then processing in Excel, and then finally writing notepad files, and then importing these files into design modeler, and then domain creation and the file export for the ICM CFD or some other measure, and then splitting the geometry for the map meshing to be done in the Ansys meshing. So first thing is the airfoil nomenclature. The airfoil is a combination of the two parts, upper and the lower surface, and at the upstream where the flow is coming, which is coming from the left side, the point they meet is known as the leading edge, and when the airfoil is ending and two surfaces meet, the second point is known as the trailing edge, and the line which is joining the leading edge and trailing edge is known as the chord line, and this is known as the chord length. And the camber line is the line around which we have the thickness distribution of the airfoil. So for symmetric airfoil, the camber line and chord line are the same, but for the cambered airfoil, they are different. And we put the thickness distribution around the camber line, so maybe you can see here that we have different thickness from the chord line on the upper surface and on the lower surface. Also we have the location where we have the maximum camber, and also we have the maximum thickness. Maximum thickness is the thickness of all the sections on the chord length. So you can see here we have the maximum, the distance from the lower surface and the upper surface. And here we have the maximum camber, which is the distance between the camber line and the chord line. And then we have the angle of attack, which is the angle between the wind and the chord line. So if you turn the airfoil, or if you turn the wind at some angle, if they are making the 5 degrees, so the effect will be same and you will get the same results. And here we have the two different airfoils, symmetrical and the cambered. And symmetrical airfoil, you can see here the camber line and the chord line, they are coinciding each other. But in the case of the cambered airfoil, you can see here we have the leading edge and here we have the trailing edge. So if I join this one with a straight line, this is the chord line, and this line which is going through center of the E section is a camber line. So at the E section, the midpoint is the point for the camber curve.